Hi, welcome back. I have my little friend here. She's going to be with us today, or she's going to sit on my lap until she jumps down. Right, Kitty? You probably see her walking around the background sometimes. She's really good at doing that. Okay, so in this part of chapter 14, we're going to take a look at different ways that the pathogens can be transmitted from typically person to person or from environment to person. There's the tail. So we have a couple different kind of groupings. There's three major categories, if you will, of these different types of transmission. We have contact, vehicle, and vector. And then within each of these, there are some subcategories. So let's take a look at the first one is contact transmission, direct contact. So direct contact, we can see in a little table, and this is taken straight from your textbook, handshaking, kissing, sex, insect bites, those types of things. Let me back that up, not insect bites, other bites. Insect bites are part of our vector towards the end. So animal bites, humans transfer pathogen, human bites transfer pathogens actually pretty well. So I've just put some pictorial representations of ways that you could get direct contact transmission. Then we have indirect contact transmission. So it's still contact, it's under the category contact transmission, but indirect contact is you're not touching the actual other person. It's not person-to-person contact. So drinking glasses, toothbrushes, toys, punctures. So I've shown you some things that you could get transmission from. Doorknobs, money, remote controls, toilet handles, needles. You know, all the things that we are needing to be careful about now in our global pandemic is that's why we're washing our hands. We are cleaning our surfaces because these virus particles can land on these surfaces. If we touch those surfaces and then touch our mucous membranes, this is how that disease can be transmitted via this contact transmission. Okay. And so the last category of contact transmission is droplet transmission. So this is this and the very first one of our vehicle of the next one is kind of where people are kind of up in the air right now, specifically with coronavirus transmission, is initially it was said to be part of this droplet transmission. So that's why the 6 feet rule, 3 feet or 1 to 2 meters, basically. If you can stay physically distant, then the droplets, let's say the virus is coming out here in these little droplets. Respiratory droplets are large, they're heavy, and so they're going to fall down to the ground. And the idea is they will fall out of the air less than a meter away. So if you do the 6 feet rule, then you are 2 times the distance away from the people, from one person to the next person. You'd have 6 feet in front of you, which is going to be protecting you from any of this droplets transmission within 1 meter. So coughs and sneezes, that the pathogen is in these heavy droplets that are going to fall down to the surfaces. This is what they're talking about with droplet transmission. They're finding now, moving into that second category of vehicle transmission, is whether coronavirus is actually airborne. Can it linger? So airborne is it can stay in the air and just kind of linger for long periods of time. Those are a little bit more dangerous because of droplets, you can kind of see that they're going to come out and then they're going to fall straight down. And so the physical distancing is a good way to prevent that. When something becomes airborne, it's a lot harder to control the distribution of that particular pathogen because now it can hang out in these really light, maybe dust particles or really small respiratory mists that can linger in the air for longer periods of time. So it's a little bit more increasing to transmission, increases the transmission when something becomes airborne. So I think that's one of the reasons why the World Health Organization is maybe kind of holding back a little bit on whether it is airborne. And so when I'm recording this, this is in the middle of July, no, beginning of July-ish. So that was kind of the thing that's happening with researchers, and is a WHO going to announce coronavirus as being airborne? By the time you watch this, it may already have been categorized as that. I can't tell the future. I'm just talking about what I know now. So for example, things that we know are transmitted by this airborne transmission: chickenpox, influenza, measles, tuberculosis, coccidiomycosis, which is a fungal infection. So these are things that are transmitted via airborne. So sweeping up dust particles, air conditioners can cause things to become airborne, or our respiratory coughs and sneezes and talking and things like that, if it is airborne, can linger in the air a lot longer. So the air is the vehicle that's carrying the pathogen. The next is water. So water is a vehicle that carries the pathogen. So these are kind of the fecal oral route infections where you might have contaminated water and then people are drinking the contaminated water. Like you can see here in these developing countries, cholera, giardia, Campylobacter infections, things that you're going to acquire by consuming contaminated water. And to go along with that are foodborne infections. So your food safety, if you've ever worked in food service, you had to take your food handler's card. I don't know if they still do that, but I remember, as a high school student going, getting a job at the local restaurant, you had to learn how to properly handle food temperature and avoid cross-contamination. So this is a big no-no. Don't put chicken juice when you're cutting your vegetables that are not going to be cooked. So a lot of times the bacteria, the viruses come in with certain foods, and if they're not prepared properly or heated properly, then those are going to be sources of infection. So food poisoning, hepatitis A, tapeworms, typhoid fever, toxoplasmosis, listeriosis, all of those examples are of diseases that come from improperly treated food. And so the food is the vehicle. So we had air, water, food. Those are our vehicle transmission examples. And then our vehicle is bodily fluids. So saliva, blood, urine, reproductive secretions, earwax, sputum, those are going to be bodily fluid transmission. So you'd have to come into contact with somebody else's bodily fluids to be able to contract that infection. All right, and then our last grouping, right, so we had contact transmission, vehicle transmission, and this is vector transmission. There's two types of vectors. We have biological vectors and mechanical vectors. Biological vectors are biting insects. So insects that actually penetrate your skin and suck your blood, usually. So we have mosquitoes, ticks, fleas, biting flies, bed bugs. I don't have that picture on there, but they would count lice. Mites are in this little list down here. So these guys carry the pathogen usually in their salivary glands. They bite you. They secrete their saliva, which is probably going to have an anticoagulant in it. So then they can suck your blood because that's where they get their food. And then the pathogen is transferred into your system via their sucking mouth parts. And there's a lot of these. There's lots of our infectious diseases that are vector-borne. So Chagas disease, Lyme disease, malaria, plague, Rocky Mountain spotted fever, typhus, and yellow fever. So biting insects are the biological. Okay, so excuse me, our other vector is mechanical vectors. So these are not biting insects. They're still insects, but they're like flies and cockroaches. That the pathogen is on their body parts. So I know it's super grody, but imagine like where do flies like to go and hover around and land on, right? Piles of poop. And then they come and land on your picnic and then you eat your picnic food. And so that's how you can acquire the E. coli, the salmonellosis, the trachoma. So these are things that can be transferred via the body parts of these insects. So in your book, there's a table just to show some different biological vectors and their diseases and mechanical vectors and their diseases. So mosquitoes, ticks, fleas, lice, blood-sucking flies, blood-sucking bugs, and mites are some examples of biological vectors. Houseflies and cockroaches are examples of mechanical vectors. So if you're interested in the diseases or the bacteria or virus or like a protozoa, you can take a closer look at those. All right, so that finishes up that section of transmission of disease. So the last video is going to be on kind of studying infectious diseases and epidemiology, and that will wrap up our chapter 14 discussion. All right, thanks so much. I'll see you next time.